Precision transitions have 4 pitch transition rules: a general pitch transition rule and 3 basic pitch transition rules. The general pitch transition rule is: determine exact pitch attitudes and power settings for all normal flight maneuvers. This demonstration illustrates Rule 1, which is called the changing both rule. It states, when changing both flight path and airspeed, set the new pitch attitude and power settings simultaneously and wait for the new flight path and airspeed to stabilize. This demonstration shows how the rule is applied to the transition from level flight to a stable climb at a reduced airspeed. The data plot view will be shown first, followed by the same transition shown in the flight deck view. We will enter the climb by simultaneously setting 8 degrees of pitch and an EPIR of 1.36. We'll increase the plotting speed in order to see everything occur in a timely manner. Notice that the airspeed is decreasing toward its target value of 200 knots. As the airspeed reaches its target value of 200 knots, a slight decrease in pitch attitude will be required as the altitude increases due to decreasing thrust. Setting the climb pitch attitude and power together and then waiting allows the flight path and airspeed to stabilize at their correct values at the same time without additional changes in pitch or power. However, due to reduced thrust with increasing altitude, when the desired airspeed is reached, pitch must be reduced as altitude increases to maintain a constant airspeed. The climb entry maneuver will now be repeated in the flight deck view. We now simultaneously set the new pitch attitude of 8 degrees and the EPIR to 1.36. The flying speed has now been increased. And note the gradual decrease in airspeed approaching 200 knots. And after reaching 200 knots, we'll see a slight decrease in pitch attitude as the altitude increases and thrust is reduced with increasing altitude. This demonstration shows how the rule is applied to the transition from level flight to a stable descent at a reduced airspeed. The data plot view will be shown first, followed by the same transition shown in the flight deck view. Initially, we are at 13,000 feet and 300 knots, requiring a pitch attitude of 0.9 degrees and an EPIR setting of 1.11. We begin the descent by setting a pitch attitude of 0.5 degrees and an EPIR setting of 0.96, which is the idle thrust setting. The plotting speed is now increased. Note the gradual change in airspeed and vertical speed toward their target values of 240 knots and 1,000 feet per minute. A slight change in pitch attitude is required due to thrust changes due to altitude. Note that the speed has stabilized at 240 knots and the vertical speed at approximately 1,000 feet a minute. Setting the descent pitch attitude and power together and then waiting allows the flight path and airspeed to stabilize at their correct values at the same time without additional changes in pitch or power. However, due to slight thrust differences with decreasing altitude, when the desired airspeed is reached, a small adjustment in pitch may be required as altitude decreases in order to maintain a constant airspeed. We will now repeat the demonstration in the flight deck view. We now set the final pitch attitude of 0.5 degrees and idle thrust. Plotting speed has now been increased. Note the gradual change in airspeed toward 240 knots and the vertical speed toward 1,000 feet a minute. Now, a slight change in pitch due to altitude effects, and the vertical speed remains close to 1,000 feet a minute and the airspeed at 240 knots. This demonstration illustrates Rule 2, which is called the changing airspeed rule. It states, when changing airspeed only while maintaining the same flight path, change the power setting first. Then coordinate pitch attitude changes with airspeed changes to maintain a constant flight path. This demonstration shows how the rule is applied to the transition from one airspeed to another while maintaining a constant altitude. An airspeed increase is shown first, followed by an airspeed decrease. The data plot view will be shown first, followed by the same transitions shown in the flight deck view. On this plot, we are initially at 15,000 feet and 250 knots, which requires a pitch attitude of 2.1 degrees and an EPIR setting of 1.09. To change speed, we will first increase the EPIR to 1.30. and also increase the plotting speed. Note that as the airspeed is increasing, the pitch attitude must be decreased along with the airspeed change. And slightly before reaching 340 knots, we will reduce the EPIR to its final value of 1.12 to maintain the airspeed constant at 340 knots. Next, we will do an airspeed reduction. In order to decelerate to 300 knots, we will first set the EPIR to 1.05. And as the airspeed is reduced, we must gradually increase the pitch attitude in order to maintain the altitude constant. Slightly before reaching 300 knots, we will have to set the final EPIR setting of 1.11 in order to maintain the airspeed constant at 300 knots. Lift must remain approximately constant for altitude to remain unchanged. The lift depends on airspeed and angle of attack. To change airspeed, set a new thrust value. Then coordinate pitch attitude changes with airspeed changes to maintain a constant lift and altitude. Coordinating pitch with power will result in an unwanted change in altitude. Overpowering or underpowering to change speed and reset the correct power setting as airspeed approaches the desired value. Making a power change beyond the value necessary to maintain the next airspeed is only necessary in the region of neutral command or reverse command. Jets operating at cruise speed and propeller airplanes at most speeds operate in the region of normal command, where changes in drag will accomplish the change in airspeed in a timely manner without overpowering or underpowering. We'll now repeat these airspeed transitions in the flight deck view. Power is now being increased, and as the airspeed is increased, we see the pitch attitude decreasing, maintaining a constant altitude. And slightly before our target airspeed of 340 knots, we will reduce the power to the value necessary to maintain the airspeed constant. Next, we will do the airspeed reduction. First will be a power reduction. And as the airspeed decreases, we must accomplish an increase in pitch attitude. Note, while this coordination is taking place, the altitude remains constant. Slightly before reaching our target airspeed of 300 knots, we will set the power setting necessary to maintain it. This demonstration illustrates Rule 3, which is called the changing flight path rule. It states, when changing flight path only, while maintaining the same airspeed, coordinate pitch attitude changes with power changes to maintain a constant airspeed. This demonstration shows how the rule is applied to the transition from one flight path to another while maintaining a constant airspeed. A descent entry is shown first, followed by a level off at a new altitude. Both will first be shown in the data plot view, followed by the same transitions shown in the flight deck view. Initially, we are level at 15,000 feet and 300 knots. Requires a pitch attitude of 0.9 degrees and an EPIR setting of 1.11. To enter a descent at the same 300 knots and a vertical speed of 1,000 feet a minute, we will set the pitch attitude to minus 0.6 degrees and the EPIR to 1.01 at the same time. Notice that the airspeed remains at 300 knots and the vertical speed stabilizes at 1,000 feet per minute. As we approach our target altitude of 13,000 feet, we will return to the prior pitch attitude and power setting that maintained a level flight at 300 knots, but we will use a slight lead in altitude, since during the transition the vertical speed takes time to return to 0 feet per minute. This lead in this example will be 17 feet. Here we see the change in both pitch and power occurring. The airspeed remains at 300 knots and the vertical speed goes to 0 as we reach 13,000 feet. If power is changed without a corresponding pitch change, an unwanted airspeed change will result. To change flight path while maintaining a constant airspeed, coordinate a pitch attitude change with the power change. We will now repeat the prior transitions in the flight deck view. Notice we have just made a change in pitch and power together, and the airspeed remains at 300 knots and the vertical speed has stabilized at 1,000 feet a minute. Notice that at this new pitch and power setting, the airspeed remains at 300 knots and the vertical speed at 1,000 feet a minute. As we approach our target altitude of 13,000 feet, remember that we need a slight lead in the change in pitch and power, since the vertical speed takes time to stabilize at the new value of 0 feet per minute. There is the coordinated change in both pitch and power. The vertical speed stabilizes at 0 as the altitude reaches 13,000 feet.